We're well underway into the FRC rebuilt season. Let's take a look at some of the best prototypes communities come up with to help make your robot better. You can see that in the end, we start to arc here, whereas at the start, we're arcing a little bit over here. I'm Coach Pratt, and I've been teaching robotics and design for over a decade now. And today, we're going to take a look at some of the best intakes, outtakes, and climbing mechanisms that I've scoured the internet to be able to find that the community has come up with for this week. I'm also going to highlight for you some important data on different fuel tests that one of the teams in Australia has done that you should go take a look at as well, because it's really going to change how your team fundamentally thinks about intaking and outtaking the fuel for this season. So let's get started with some intake prototypes. First up, we've got a double PVC roller from Team Rembrandt's FRC 4481. Let's take a look. I love that they've got a quick little push cart here to be able to pick these things up. I think it's a great way of prototyping in sort of a lo-fi manner, so you don't have to have a full chassis all the time. It also is a surprisingly decent way of testing high throughput with an actual robot driving into these fuel as well. Excellent job on this, and I think that it looks like a 2 PVC roller, one up the top, one down the bottom, is a pretty solid test, and we'll keep taking a look at this down below. We've also got a similar idea here from Littleton Robotics, which is 6328. They also have what looks like several different PVC rollers. It looks like they have 3 PVC rollers on there, as they've got one additional one up at the top for doing 4 on the sides as opposed to a 2 wide side on that intake. Next up, we've got from Team 2062, and they were doing a little bit of just kind of low testing on a legacy point from a previous season here with a couple different PVC rollers and feeding in the balls. One thing I will say about doing tests like this, I think it's better if you can to take your robot and move it into the fuel rather than taking the fuel and moving it into your robot. And the reason I say that is because then the robot is controlling that fuel as opposed to you controlling it and adding a little bit of extra guidance in. You may or may not get accurate tests doing this as you are pushing them into that robot, so you might get slightly more accurate tests on the way out. One thing I want to highlight from, again, this Team 9062 is it looks like as they're doing some tests with this legacy intake that you may end up with a dead zone on some of these from some previous seasons as well. So you might want to make sure you're checking for those kind of things. And also a creative use of a pool noodle here, because you are not allowed to use those for bumpers anymore. You got to find something where to do it with. Next up, take a look at climb here. We've got the Fem Maidens here, 2265. And they've got a very similar hook, and this is a passive hook that I've talked about before from the FTC into the deep season, which was the 24-25 season. So this hook is able to pushing up. It is on a spring reload, and then it's able to then clip itself back up. And how you might go about using one of these is actually pretty similar to what this team here from 3255 has come up with. So they also have a passive hook mechanism here. The idea is that you have a sort of hand-over-hand climbing mechanism. So you have one section of your elevator lifting up to be able to just hold yourself in place, and then the actual main lifting comes from the other main arms in and of themselves. It's a really interesting design to take a look at. I like that they have these passive wheeled rollers here to be able to keep themselves off, as well as reduce a little bit of that friction. Another option you could do is something like an acetyl plate, and like a rather slippery plastic in that case. And acetyl is a nice, sometimes it's called Delrin as a brand name, or polyacetyl. It's a nice, really slick plastic that's quite used for slides. It's actually the similar type of plastic you've ever seen on ice hockey rinks for iceless ice hockey rinks. Acetyl is that type of plastic they typically use for that because it is such a slippery surface that it actually can mimic the surface of ice, which can be quite useful. Next up, take a look at some outtake prototypes here. We've got Team 334 Tech Knights testing for some accuracy going into that hub. I think what's really important here on this is that I think that teams really need to highlight high throughput through their shooters, and having perhaps a multi-shooter that's capable of either a single hood that has a really high throughput, quite a heavy flywheel to be able to make sure that it can hold all that throughput, or a multi-shooter so you can shoot 2 or even 3 of these fuel at a time to be able to get it in, because high throughput, as we're seeing in the FTC Decode season as well, seems to be winning matches as well. So next up, we've got Team iBots 2370. They've got an interesting method here for testing high throughput, as they have just a long channel with a bunch of fuel stacked up so they can see just how accurate is their shooter with a really high throughput. They've got another angle on this shooter on the back end here, right here, where you can also see that they're clearly able to change the angle of their hood too. So they have quite a chonky gear on there. I really like seeing dual herringbone gear out of 3D printing. If you don't know what a dual herringbone gear is, a herringbone is that kind of flashed or that angled piece, and you've probably seen herringbone like hardwood floors before. Dual herringbone is, of course, a 2 herringbone pattern. And the really nice thing about these for 3D printed gears is that it is one of the strongest gear alignment for teeth that you can come up with. It's very hard for these gears to demesh from one another. The reason we typically don't see these gears out of things like aluminum or steel is that it's an absolute pain in the butt to manufacture on a CNC machine. But manufacturing on something like an additive structure like FDM printing makes it really easy to be able to produce quite strong gears in that respect. So the idea is, if we can look at it from the side here, if they are able to zoom in, we might be able to go back as they change their angle here. The idea with here is that you've got the back section of this hood. You have a very rigid structure up at the front back here. This is a very rigid structure on the back section up in here. And then in here, you've got a hood that's capable of moving up and down on that to be able to change the angle of your shot. And that allows you to either have a higher arc or a lower arc and higher RPMs, depending on how far away your shot is from the goal. It's a great way of having a little more adaptation, provided that you have a high enough throughput capability on your flywheel here. So nice job on this one, team iBots 2370. We've got another dual shooter prototype here from Titanium Titans 4467, also with a similar kind of idea to be able to show a different kind of throughput. And when you're looking at these tests on these different throughputs, I think something that's really important is looking at that arc pattern. So filming this in such a way that you're able to see the entire shot while you're doing it, and looking at how that arc pattern is changing over time can be really useful to see if you have a high enough throughput on your shooter, or if you might need to add a little bit more torque to your motor, add an additional motor, or a little bit more mass on your flywheel so that it's capable of keeping up with all of those fuel moving through. Next up, we've got team 5951 Makers Assemble. And they've got a sort of belt shift here to be able to test their fuel moving through. Quite a high throughput on this shooter as well. And I think we're definitely going to see that as a predominant meta for teams coming in. One thing I'm wondering about with these belt style systems is if the belt has enough throughput to be able to push these things into your shooter at a certain point. You might need to have slightly faster rolling belts. We'll see where time goes. I'm also curious what happens if you have a fuel that lines up on these belts. If it's not perfectly aligned, is it still going to move these things? So testing this with a large hopper might be a good way of testing it more in a real world scenario. I'm always a big fan of testing things in real world scenarios as much as you can once you get through that sort of initial minimal viable prototype. And then last up here, we've got Littleton Robotics with, again, a pretty impressive throughput and we're moving through. So it is 100% capable for teams to be able to have enough mass and enough torque on their flywheel or their outtake to be able to have a quite high throughput. It does look like they're actually starting to lose a bit of that throughput at the end there, as we're talking about with the arc. As I was talking about before, you can see that in the end, we start to arc here, whereas at the start, we're arcing a little bit over here. So it clearly hasn't affected things too much at this moment, but we might need a little bit more mass or a little bit more torque on this system just by looking at that arc pattern. So this is a great example of having enough of that camera view in as you're doing your testing. And as I always like to say, testing does not start until the wheels are on your robot. The last up here, I want to show off some tests here that Thunder Down Under has been doing, Team 332. I think this is really important as our most latest team update that came up, that there's going to be manufacturing differences in the fuel. And because of that, you're going to have different levels of compression. And the ones that are pre-ordered are far more dense than the ones that are being shipped out now. So the kitted parts versus the antimeric fuel is quite a bit difference in tests. I'm not going to show through all of these tests that they've been doing, but they do a lot of different compression tests between the AndyMark versus the kit of parts. They have a bunch of different data on here, as well as actually cutting one in half and then doing some sort of rudimentary compression tests with different measuring instruments as well. It is 100% worth a watch for teams to go take a look at, to make sure that you're designing things in such a way that you have different variability throughout these. I think another thing that's going to happen is that as this foam degrades slightly throughout the season, you may end up finding that you have different compression rates as well, and designing for more compliance in your design is going to be really useful instead of having absolutely perfect, cutting things right to the teeth on that with your designs. Very last thing here I want to highlight is from Team Critical Circuits here, and they've been doing a little bit of testing with swerve drive pushing up against tank drive. I think this is something that we've been seeing for a long time. Now, obviously, this team's not on the carpet while they're doing this testing, but it's something we've seen for a long time, that tank is, stronger in defense than most swerve drives typically are. But this does highlight the importance of doing that testing. In previous seasons of FRC, we've seen things where swerve drive has been really dominant. But I think that this season is one of those that's really going to make teams stop and think about whether swerve drive is the strategy to be able to have your base drivetrain set up on, because I'm not so convinced that it will be the major strategy up on this, particularly if you have some sort of rotating turret on top of your hood as well, so that you can still auto-align yourself towards that hub, having that benefit of extra defense on your tank drive, particularly because in this season, if you remember, there's no actual protected zones outside of an end game when you're in contact with your tower. So the opposing alliance and all three robots can be in your alliance's zone while your hub is active, playing a lot of defense against you. So having a robot that is quite strong and quite resilient to being pushed around by other robots is going to be a big boon for your team as well. I'm curious your thoughts on where you think metas are going to be going. Let me know in the comments down below. If you've got an interesting prototype running mechanism you think the community can benefit from, I've got a submission form. You can submit that down below for FRC Saturdays. And as always, best of luck out there this season.